Hello everyone, I hope the audio works and in the last rows, speak up, okay. So welcome to Measure What You Manage, Transparent Energy Consumption of Cloud Infrastructure. So in the following 10 minutes, I will really quickly try to take you on our journey from measuring and understanding energy consumption focused on cloud environments. And we uncovered some challenges that we faced while mapping software workloads with physical resource usage. And we know that today cloud emits up to 4 or up to 6% of the world carbon emission, which is a lot. And also we know that this will contribute in the near future even more. So normally I ask, do we have any public or private cloud providers with us today? And if so, I would like to ask if you know the ecological footprint of your cloud environment, for example, for the last year. We are not only talking about energy consumption. So, normally if I would say, if anyone does it already, my reply would be, wow, let's talk about after this presentation. But if not, why? And isn't it something that your consumers and also the consumers of your consumers would probably like to know? To make it even more concrete, in 2027, global AI demand could be responsible for 4.2 to 6.6 billion cubic meters of water withdrawal. And that's 4 to 6 times Denmark's total annual water withdrawal, which is a lot. I would argue that it's really important to determine the whole environmental impact of distributed digital systems and the software running on them. So when we look at the impacts, actually, let's talk at holistically looking at the environment impact that we face. So there are various approaches and attempts to really systematically map these potential impacts. For example, the compute-related, which includes the embodied and the operational, which we talked about, or the session before talked about, and the immediate application impact. They can be optimized because it's something like transportation and electricity costs, but more importantly, we also have the system-level impact, right? So the rebound effects, for example, by increasing the GHG emissions. So the solution could actually be looking at the life cycle assessment, which enables us to actually look at the environmental impact of these digital services and record them over the entire life cycle. Environmental impact categories, since I only have 10 minutes, I will quickly let you read through it. So it's about the energy demand, global warming potential, the resources it costs, water consumption, electronic waste as well, and the pollutant effects. Coming to our research project, EcoDigit. It's funded it was funded as a part of the Green Tech Innovation competition of the German Federal Ministry of Economics and Climate Action. Here's our website as well with all of the information. And our research was, the goal of our research project is, as said, to assess the environmental impact for distributed systems, but it's across cloud, edge, and end devices. I will talk mostly about cloud, but it's a bigger project because we consist of a community of partners from the science, research, and industry backgrounds, so Adesso, Siemens, but also the Institute of Applied Ecology and the German Society of Informatics are part. And me as well, so we are the Open Source Business Alliance, a German nonprofit that operates a network of companies and organizations developing and building using open source software. So a real quick look into what actually happens in EcoDigit. I try to map it out as like a workflow. So I want to really quickly just show you what we are developing on the meta level. So it's called the test bench. And there you can define with IIC your infrastructure. Then digital twins get created of these different infrastructures, so end devices, cloud infrastructure, etc. And a system under test can be executed on these test bench. And then we collect metrics and use the methodology proposed by the Institute of Applied Ecology. We implemented it, but it's using so-called energy profiles and regression models to combine not only the usage phase, but also, as explained, the LCA using the prior shown environmental impact categories we focused on. So in the manufacturing and in the disposal phase, but also the resource and energy consumption of the workload while running, so in the usage phase. This would be how we actually, but as said, limited time, so maybe make a picture, and it's also online as well. But this is actually how we get the data. So it's actually like static energy profiles. Yeah. And as a result, to move on further, you could define how an actual infrastructure combining of different platforms contribute in its complete life cycle. And for cloud, obviously, energy consumption is the most important aspect for us. I mean, life cycle as well, but getting this information is really hard. It's even harder if you also want to look at the hyperscalers, because their access to relevant data is highly limited. I researched a lot, so there's no exposure of MSR, and there are some solutions like the Boa Vista API and how they do it. And for example, there's also the Cloud Carbon Footprint, which is also an open source community using the billing APIs of the hyperscaler. But what's very limited in these, what's very limited is still the information on the management overhead. But that's a lot on hyperscalers. So so to create energy profiles, we used a really similar way. It was first introduced by FEDS, and now it's part of the Boa Vista API. But this, actually, you look at the bare metal, you do stress, you collect certain RAPL metrics and align them with the utilization of certain processes, and then you use an instance number of virtual CPU ratio compared to the bare metal number of virtual CPUs. That's just really quickly how an energy model is created. So this is rather an estimation, and you use regression to estimate the actual usage after deploying it as a digital twin. But how nice would it be to use an open cloud where you can actually access host levels and find out what is the scaling effects, what is the baseline of the management servers, and how does it contribute to the actual workload. This is what we did with the help of the Soaring Cloud Stack. It's based on OpenStack for the infrastructure as a service component. And so with our cloud provider technical partners, plus Server and Scale-Up, we built 2 different cloud environments. And then we use sensors, so power distribution units, to get the physical actual measurements. So in order that we can at some point really see how accurate is, for example, a solution, a few of you might maybe know, Scaphandre, or maybe even Kepler, MSR metrics, how accurate are they when you take the physical measurement as a baseline? Maybe you need some sort of distribution factor or something like that. So we faced a few issues, starting off with 2 different environments. One is based on OCP hardware, meaning you don't really have the option of having energy measurements per device. You only can measure it per rack. So you need a distribution factor of how much which server, so node, actually contributes. For that, we needed to make a concept that works for different infrastructure, which can be very heterogeneous. And that was the goal. So we can really estimate the baseline of the management services, and then as well the workload running on it. I need to skip it, sorry. It's just time-wise. But this is, I actually got this graph from, because it explains it really well what we are doing, but it's from the Kepler project as well. So we are trying to find out, we have a stressor which runs certain a different number of virtual machines with the different flavors. We can estimate it inside these machines. We have StressNG and other tools to collect these metrics. And to quickly jump into this, we have the physical measurements with different solutions, whereas RAPL is the one we really want to look at how accurate this is. So we focus on actual physical measurements and allocations. For the software-based measurements, for the Sovereign Cloud Stack, Prometheus High Availability Status is already implemented, so we use a lot of different exporters for all the process, container, and virtual machine levels, where we actually just use Scaphandre, which is running really nicely, but also I cannot, with 100% of confidence tell you if these numbers are accurate, and that's the goal of what we are trying to do. So, and then to be on time, the next steps are we still need to work on the data isolation and the redefinement of the allocation rules. And we need to integrate the runtime monitoring, because I explained we have the static energy profiles, which we can already create. But the question is, when you have a real production cloud, how would these static energy profiles change? So this is why we need it, and are still working on it. And yeah, and the reporting functionality at the moment is only implemented as Grafana dashboards, but we want to have it as a service, as a standard for the sovereign cloud stack. Okay, this was 10 minutes, very fast, but thank you. Any questions?
How do you measure the power used for cooling the data center?
Again, sorry.
You have to cool your data center?
Yeah.
It costs a lot of power?
Yeah.
How do you measure it in this model?
Yeah, this is why we have the technology partners, Plus Server and Scale Up, because I actually am not I don't have a deep knowledge of how data centers are actually, what they are already measuring. And I thought they had like very great, they had already solution implemented to really have maybe some sort of exporter to get these information, the cooling, but allocated to this one rack, because they have hundreds from racks, different cloud platforms. They have private cloud, but also their own public cloud. And in our rack, for example, are a few servers of a different cloud environment. So how can you allocate the cooling data which they collect to specifically this cloud environment? That's a great question, and I'm still working with the cloud providers to completely answer it. But at the moment, it's more like we collect bills of materials with the information on the, like it's you could say a static approach. They fill out like how much cooling energy cost, and like they give us the details, and we can then use some sort of allocation. Okay, you have a certain amount of cloud environments. Our has this size, and then we try to allocate it. A great solution we don't already have, but it's a really good point. It's still in the research discussion.
Thank you so much.
Okay.